Let's refactor the shopping cart to help grow it more easily in the future and make it even more interactive. First, we are going to use a custom type with payload for the on-click messages. Second, we are going to use let expressions to separate some definitions. Third, we are going to add a small feature to show prices for each product in the shopping cart. Finally, we are going to use an extensible record. Switch to Visual Studio Code on the demo machine. Notice the 3 message variants for the 3 buttons of the shopping cart. Let's replace them with one message variant which has an integer payload. Control-click on a variant to go to its definition. Replace these 3 variants with only one, quantities, with an integer payload. The payload is going to have some arbitrary values, 2 for incrementing, 1 for decrementing, and 0 for resetting quantities. As we change the message definition, the compiler is no longer happy. We need to refactor the view and the update. Let's start with the view. Replace increment quantities with quantities of 2. Add some parentheses to enforce priorities. Do the same for decrement quantities. Replace with parentheses quantities of 1. Also for reset quantities, parentheses quantities of 0. The compiler is happy about the view, so let's refactor the update function. Replace increment quantities with quantities of 2. Next, replace decrement quantities with quantities of 1. Remember that case branches must cover all possible values. So far, we only covered these 2 integers. Let's replace reset quantities with quantities of underscore, which means any other possible integer value, including 0, to return the initial model. The red squiggles are gone, which means the compiler is happy again. Very good. Before refreshing the page, we can do another bit of refactoring. Notice that the initial model is named products model. As a convention, it's a good practice to call it initial model, since it's a clearer name. To rename products model, move the cursor to it, then press F2, type initial model and press enter. Visual Studio Code took care of renaming it everywhere, including its definition. Save the file. Next, let's refactor the update function to extract these 2 into a let expression. Above case, enter let in. The let block is empty, which makes the compiler very nervous. Here is a trick. Add a temporary definition like a equals 1. Red squiggles are gone, so the compiler is cool for now. These 2 are very similar. Let's refactor them into a common function with an argument for the actual quantity. Select the whole line. Now either click the code actions icon or press Ctrl-. We get 2 options: extract a new function to enclosing let or to top level. We only need this function here, so let's select the first option. Rename it to change quantity. Now to get rid of the hard-coded value, add an argument, let's say Q for quantity, and replace the 1 with Q, then add a 1 as argument. The compiler is happy again, so we can replace this code with a call to change quantity of -1. Finally, get rid of the initial temporary definition, since the let block is no longer empty. Save the file, switch to the browser, and refresh the page. The application is still working, which means our refactoring was very successful. Let's add a new column to the shopping cart table with the corresponding prices. Back to the source code, we need to change the initial model to include prices for each product. Add a new field name unit price with some simple values: 7 for cheese, 5 for bananas, and 3 for milk. We also need to update the definition of product so that it includes an unit price field of type integer for simplicity. Next, let's update the cart view to include price in the table header. Copy and paste and change to price. To update each row, Control-click on Item View to go to its definition. Copy and paste the last row. The price is the result of multiplying quantity and unit price. Save the file, switch to the browser, and refresh the page. The new prices column appears in the table with the expected values. When clicking the buttons, its values are updated to reflect the new quantities. Perfect! Finally, let's refactor the price logic into a separate function using an extensible record as argument. The new calculate price function has an argument. Let's call it extensible just to make it very clear. For now, it returns the output of multiplying quantity and unit price after converting it to string with some piping. Add some inferred annotation. Notice this looks like a new extensible record. It only has the required quantity and unit price integer fields, and it doesn't care about any other fields. We can call calculate price with the product model, which also has some other fields. Furthermore, if we use this extensible record in other places, we can define a new type alias for it. For example, type alias item A equal to, then copy and paste this part. Then replace it with item of A. Save the file, refresh the page to confirm that the shopping cart is working well. Notice that the Elm compiler has helped us along the way of our refactoring journey. Next, let's add a new feature to the shopping cart.